Welcome to my channel, our chemistry class with Ms. Vishaka. In today's video, I'm going to discuss about equilibrium constant Kp, which is in terms of partial pressure. Equilibrium constant in terms of partial pressure is basically introduced for gaseous systems. We get some example for such gaseous systems. To write the Kp expression for this type of reaction, we call it is the equilibrium constant in terms of Kp, partial pressure of products. So we should get the products partial pressure. At the same time, we have to divide by partial pressure of reactants. So we should divide this value by partial pressure of reactants. So this ratio is a constant. So the products here would be that the partial pressure of SO3, there are two of them in the balance equation. So we should divide that partial pressure of SO2 again 2 to be multiplied by partial pressure of oxygen to the power 1. If you need to get the units for this one, if we measure that pressure in atmosphere, so we can get this answer again in terms of this equilibrium constant, in terms of this value would be atmosphere square upward and the atmosphere to the power 3 downwards. So our final equation is PSO3 to the power 2 divided by P. It is that the partial pressure of SO3, partial pressure of SO2 to the power 2 multiplied by oxygen. Finally, it would be atmosphere minus 1 would be the units. This is the second example being chosen. So the Kp is equals to partial pressure of products divided by partial pressure of reactants. So it is the partial pressure of reactants. So in this context, so it is the products is the partial pressure of ammonia to the power 2 divided by the nitrogen to the power 1 and the hydrogen to the power 3. Once we substituted the units here, it should be atmosphere to the power 2 is your numerator, denominator become atmosphere to the power 4. So obviously the final answer with the units would be final units. This get cancel atmosphere minus 2. So this get cancelled. The overall Kp value can be calculated with the units atmosphere minus 2. As the Kp expressions dealt on before gaseous reaction. For this type of two solids are involved in an equation, so the Kp should be partial pressure of carbon dioxide only. As we are not mentioning the solids in our equilibrium expression, so it should be the units will be atmosphere minus 1. Now we move on to see what is the meaning of the partial pressure and how does it calculate. To understand the concept of partial pressure, I got an example here. Three gases, nitrogen, carbon dioxide and the oxygen. 4 moles of oxygen and the 4 moles of carbon dioxide and 2 moles of nitrogen are present in a mixture. With the total pressure, we call it is the pressure total equals to 2 atmosphere in this mixture of gases. So we can find a new term we call mole fraction. To introduce the mole fraction means it is equals to the number of mole of a gas to total number of gases in a mixture. Mole fraction is number of mole of a gas. It's a ratio. It is the number of moles of a gas to total number of moles. Total number of moles in a mixture of gases. So according to this fact, we can talk about the mole fraction of each of these gases, the nitrogen and the carbon dioxide and the oxygen. In this example, we say how we can calculate. Usually we show the mole fraction as ith component. I could be the nitrogen, oxygen or carbon dioxide. Total number of it is the n total is the total number of moles would be 4 plus 2 plus 4 would be 10. So in this mixture there are 10 moles are present. So nitrogen present in the 2 divided by total number of moles would be the mole fraction of nitrogen, which is zero point 0.2. It is a fraction has no units. Oxygen there would be the 4 moles, but the total number of moles 10, which make the mole fraction of oxygen zero point 0.4. Same with the carbon dioxide. 4 moles are present with the total number 10, so it gives us zero point 0.4 is the mole fraction of carbon dioxide. We can introduce the partial pressure as the pressure occupied by one gas in a mixture if allowed to occupy the given volume. So the total pressure equals to the pressure contributed by nitrogen, oxygen, carbon dioxide, as I took this mixture as example. So it is that partial pressure of nitrogen plus oxygen plus carbon dioxide should be equals to the total pressure of 2 atmosphere in this example. To calculate partial pressure of each gas, we need the mole fraction as well as the total pressure. We see what's the relationship between partial pressure, mole fraction and total pressure. So it's always that partial pressure of one gas equals to mole fraction of that gas into total pressure. So we can calculate it is the partial pressure of nitrogen is mole fraction of nitrogen into total pressure, which comes as the zero point 0.2 times the total pressure 2, which become zero point 0.4 atmosphere. Out of these 2 atmosphere, the total pressure contributed by nitrogen is zero point 0.4. At the same time, partial pressure of carbon dioxide is equals to mole fraction of carbon dioxide times total pressure. Mole fraction is the zero point 0.4 times 2, it should be zero point 0.8 atmosphere is the mole fraction of that is being created by partial pressure of carbon dioxide. Partial pressure of the oxygen is mole fraction of oxygen into pressure total. Mole fraction of oxygen again the zero point 0.4, and it is the total pressure is 2, so it equals to zero point 0.8 atmosphere. So that 2 atmosphere goes by zero point 0.4 atmosphere by nitrogen, because nitrogen is the least amount, so it's the pressure also the least for nitrogen. And the other two, it is the same amount of this would be the mole fraction, so that the partial pressure also equalize. Now you can see the total pressure. Pressure total is equals to partial pressure of nitrogen in this mixture plus oxygen plus carbon dioxide. That means when you add it up, zero point 0.8 and zero point 0.8 is 1.6 and the zero point 0.4, it comes the pressure total of 2 atmosphere. I hope was it clear for you all the relationship between the partial pressure, mole fraction and the total pressure, as well as it is how to write the Kp expression and how to get the final equation in terms of the units as well. We get one example to discuss how does this apply as it comes to the examination style questions. I have taken the example Edexcel IAL Unit 4 paper WCH14 January 2021. So this is the question number 18. I move on to the third part for this particular equilibrium has been provided. So it's your third part asking you to write an expression, the equilibrium constant Kp for this equilibrium. So the Kp is equals to partial pressure of SO3 to the power 2 in the gaseous state, partial pressure of SO2 the gaseous state to the power 2, partial pressure of oxygen in the gaseous state. So you're asking state symbols are not needed. So but anyway I can mention here. So it is the equilibrium constant expression for in terms of Kp. It is asking you to write here, so it should be this explanation, this equation give you just 1 mark. So all the information is mentioned here. What is the first task here should be write down all the given information clearly. So it says at the beginning the SO2 and the oxygen are mixed. So what you should do is the very first thing is to understand the given information clearly. So it is allowed to reach the equilibrium SO2 and the oxygen at this one would be the total pressure is 5 atmosphere, and the next important point is it is given here at the equilibrium 1.6 moles of SO3 is formed. Now we write down all these information clearly and we can see how it is initiate the answer in this question. To initiate the answer to this question, write down all the given information very clearly. Now can see the pressure total 5, there were 2 moles of SO2, 1 mole of oxygen initially, there were no SO3. At the equilibrium, only 1.6 moles of SO3 were present. So you should find these two values. What were these? The SO2 and the oxygen at the equilibrium also. So you can write down this statement would be helpful because from the initial to certain twice the X being used up, from this one certain X amount is reacted because it just one time would be reacting, twice the X is reduced. So twice the X is 1.6, which means the value of X twice the X is 1.6 means X should be equals to 0.8. So from this twice this being reacted, from this to it is reacted 2 times zero point 0.8, that means 1.6 has been reacted, what is remaining is zero point 0.4 at the equilibrium. So the equilibrium quantity remaining with the oxygen, it is 1 at the beginning. Now it used up zero point 0.8, therefore amount remaining will be zero point 0.2. So these are the equilibrium number of moles. So in this context, we can find the N total. N total would be zero point 0.4 plus zero point 0.2 plus 1.6. So it should be total number of mole become the 2.2 mole in this mixture. So you know the number of moles totally. So you can find here immediately mole fraction of all these gases remaining. With this information, it's possible to calculate the small fraction of SO2, which is the number of moles zero point 0.4 to the total number of mole is 2.2, and we can multiply with this one with the 5 atmospheres, so we can straight away calculate partial pressure of SO2. So once you simplify, partial pressure of SO2 can be found, which is 0.909. Same way we can calculate the same partial pressure of oxygen. Mole fraction of oxygen would be zero point 0.4 into total pressure, which is divided by 2.2 into 5. It is the same answer we can get here at where it is this, the partial pressure would be same number of moles would be here is present is zero point 0.4 and the zero point 0.4 remaining. So it is 0.4% to 0.2, therefore into total pressure. It is done this in total 2.2, so the partial pressure of SO2 is zero point 0.4 remaining. Total number of mole would be 2.2. That has to be multiplied by 5. So this would be the partial pressure in atmosphere. So you can see this is atmosphere and this is again the atmosphere partial pressure of oxygen, at the same time partial pressure of SO3 in atmosphere. This is the amount. So these three values to be calculated. Now it says here to substitute into our Kp expression these values and we can get the final answer of Kp. This is our Kp expression, partial pressure SO3 to the power 2, SO2 to the power 2 and the oxygen to the power 1. So when we substitute our values, we can get that this is that Kp is equals to SO3 partial pressure. We got 3.6363 to the power 2, and the partial pressure of this SO2 we got as 0.09090 to the power 2 SO2 to the power 2. At the same time 0.45 to the power 1, we get the unit as -1. So once simplified, we can get the value of Kp as 35.2 atmosphere minus 1. This is how we can calculate this Kp values when it is given the data of number of moles, total pressure, as well as it is the number of moles, the equilibrium. I hope you all understood how it is simplified. If you have any queries, you can put into the comment section so I can go through and I can give kind of any help whatever you need. Hope that you enjoyed with understood what the KP calculations are, and you can encourage us by subscribing our channel to do more and more videos of this nature. Alright, hope to meet up you soon with another video. Thank you so much for watching the video.